All right, this is the video answer key for the January 2019 Geometry Regents short response. So questions 25 through 35. Your 2, 4, and 6 pointer. We'll jump right in. Number 25 said to write an equation of the line that's parallel to the line whose equation is 3y plus 7 equals 2x and passes through the point 2, 6. So the first thing I need to know is that parallel lines always have the same slope. So I'm going to make sure that my answer has the same slope as this equation right here. In order to know the slope of this equation, it's probably going to be easier if I put it into slope-intercept form, aka y equals mx plus b, because m will tell me what my slope is. That coefficient of the x term is going to be my slope. So in order to put this in slope-intercept form, I need to solve for y, meaning I need to get y by itself. First thing I notice is this 7 is in the way, so I want to subtract 7 from both sides to cancel it from the left side. So I get 3y equals 2x minus 7. And then I have 3 times y. To undo multiplication, I want to divide everything by 3. So that gets me y equals 2/3 x minus 7 over 3. This is the same equation that I started with, it's just in slope-intercept form now. And since this is in slope-intercept form, I know that my slope is the coefficient of the x term. So my slope is 2 over 3. I don't really care about the y-intercept anymore. All I need is the slope because that's what happens with parallel lines. They have the same slope. So now I can kind of go 2 ways with this. So I'll show you both ways, both things you can do with this problem. So the first thing, my chosen method, the thing that I prefer is to now just jump straight into point slope form. Because it's the least amount of work, but there's a little bit of memorization that you have to do. If you don't know point slope form, you're going to have to memorize the format, the template for point slope form. It's just y equals, sorry, I'll take that back. It's not y equals. It's y minus y1 is equal to m times x minus x1, where m, as always, is your slope, and this x1 comma y1 is any point that you want this line to pass through. Excuse me. So why is this my preferred method? Because I know my slope is 2/3. I know the point I want it to pass through is 2, 6, so that's my x1, y1. So now if I just substitute in y minus my y1 was 6 equals m 2/3 times x minus x1 was 2, and I write it like that, I can stop, and this is a perfectly acceptable answer to this question because the question just said, write an equation. It didn't say it had to be in point. It didn't say it had to be in slope-intercept form. This is an equation of a line that's parallel to this that passes through the point 2, 6. Easy enough. So I could stop there and move on. A lot of us seem to be more comfortable with slope-intercept form. So I'll talk about how to do it in slope-intercept form. You know your y equals. So we know that we have the slope 2/3. We know we want it to pass through the point 2, 6. And if I want to put this in slope-intercept form, y equals mx plus b, well, I have my slope. I know that this is an x-coordinate and this is a y-coordinate on the line. The only thing I don't know about this equation is the y-intercept. So what I can do is I can substitute the information I know into this equation and figure out what b is supposed to be. So y is 6, my slope is 2/3, my x-coordinate is 2, and b is what I'm solving for. I have one equation with one variable, that means I can solve it for that variable. So I have 6 is equal to 2/3 times 2 is 4/3 plus b. Now I'm going to subtract 4/3 from both sides. This gets a little tricky because I have some fractions I've got to subtract. I could always go into my TI. If I have an 84, TI 84 plus, I could do alpha y equals. I don't have that on here to show you, but if you know what I'm talking about, good. Or if I know how to subtract fractions, I've got 6 minus 4/3. Of course, 6 is equivalent to 18/3, so I've got 18/3 minus 4/3, which is equal to 14/3. So that means that b is equal to 14/3. And so my equation, my answer would be y is equal to my slope was that, and my y-intercept is 14/3. Oops. What can you do? Technology. There you go. So we have two possible answers. They should be the same thing. And both are correct. Both are equally valid. One takes a little bit more work, one takes a little bit more memorization. Number 26, we've got parallelogram ABCD is adjacent to rhombus DEFG. And we've got some things intersecting. The measure of angle B is 118. The measure of angle AHC is 138. And we want to know the measure of angle GFH. This is the guy we're looking for. So let's see what we can do. Since ABCD is a parallelogram, ABCD, that means its opposite angles are congruent. So that means that angle HDC is also 118. Let's see, I've got on line FHC, I've got a straight line there. I know GHC is 138. So this angle right next to it forms a linear pair, so they're supplementary. So they have to add up to 180. So that's going to tell me that this angle needs to be 42 degrees. So this angle right here is 42. I know, let's see, this is a straight line right here. And I know that ABCD is a parallelogram. That means that these are parallel. And DEFG is a rhombus. That means that it's also parallel to that. So why is that important? Because I've got a nice little transversal right here. AGD is a transversal that intersects these lines, forming, see the Z shape here that I'm tracing? CDGF is a Z. So that means that angle FGD and CDG are alternate interior angles, so they're congruent. So if this is 118, then this angle in here is also 118 degrees. And now, completing this thing that I'm looking for, I've got a triangle right here, FGH. We know that the angles in a triangle have to add up to 180. I know two of the angles are 118 and 42. So if I add together 118 and 42, I get 160. The three together need to add up to 180. So 180 minus 160 is 20 degrees. So that means that the measure of angle GFH is 20 degrees. My tips for these missing angle problems is don't even look at what you're trying to find. Like, ignore the angle you're looking for, honestly, and just label every single angle that you can find in this problem, and any problem where you're looking for missing angles. Because what tends to happen if we know the angle we're looking for is we get too bogged down in trying to focus on that one angle that we kind of can't see the forest through the trees. So like if we go ahead and label all of the angles and then we stop we can't find anything else, and then we go look at which angle we're looking for, we might already have it, or we might be a lot closer and say, aha, here's something else that I'm missing now that I know this is the angle I'm looking for. So don't even worry about the angle you're looking for at first. Just label anything you can in the diagram and then try to figure out what that angle you were looking for is. Number 27, secants PWR and PTS are drawn to circle O from external point P. The measure of angle RPS is 35 degrees. The measure of arc RS is 121, and I want to know the measure of arc WT. So I've got my circle facts, some properties of circles. Whenever I have two line segments that intersect outside of a circle, or two lines, or two rays, I'm just going to write lines generically, but if I have two lines intersecting outside, this is key, of a circle, the measure of the angle they form the measure of the angle formed is always going to be the half of the difference of the two arcs intercepted. Come on, what the heck, man? All right, let's try that again. There we go. Of the two arcs intercepted. So what does that mean? Why is that relevant? Well, in this problem, I've got two lines intersecting outside of a circle. This intersection is not inside of the circle, it's outside. This angle that they form, we said, is going to be half the difference of the two arcs that they intercept. So when we say two arcs that are intercepted, we mean the arcs that fall between those lines. So RS, see how this arc is between those two lines? It's on the interior of this angle. That's going to be one of those arcs intercepted. And WT also falls on the interior of that angle, so that's going to be another arc that's intercepted. So what does that mean? In this case, that means that the measure of angle P is equal to half the difference of arc RS and arc WT. Or in other words, the measure of angle P, which is 35 degrees, is half the difference means subtract, of the two angles that are formed. It's just a fact to memorize. So that's my setup. I could go ahead and solve this thing if I wanted to, which I do. I'm going to start by multiplying both sides by 2, because that'll make this 1/2 cancel. So 35 times 2 is 70. 1/2 times 2 is 1. So there I go. I'm going to subtract 121 from both sides. So it gives me negative 51 is equal to negative x. And now I'll divide both sides by negative 1 to give me x is equal to 51 degrees. So that means that the measure of arc WT is 51 degrees. Shabam. Number 28, on the set of axes below, triangle ABC is graphed with coordinates a, -2, -1, Describe a sequence of transformations that would map triangle ABC onto triangle QRS. My biggest piece of advice with questions like these is, if you have a guess as to what the transformation is, like, test it out. Like, don't just write it down and move on, because you could be right about 2 of the points but off about 1, or it could seem like it's really obvious but you could be slightly off. So don't just write something down without actually testing it out. There are lots of ways you can answer this question. It's too many for me to list them all, so I'll do 2. The first thing I noticed right away is that it seems like there's a line reflection happening. And the reason I think that is because the first thing I notice is that the orientation of the points change. So whereas ABC is going in a clockwise orientation, notice that QRS, when I go in that order, is counterclockwise. So whenever the orientation switches, a reflection has to have occurred. So whenever the orientation changes, this went from a clockwise to a counterclockwise orientation, that means a reflection has to have occurred. Because rotations and translations don't change the orientation. So I'm going to try to do this with a single reflection, see if I can. One thing I know about reflections is that if I connect a point to its image, so notice that A is supposed to map onto Q, B onto R, and C onto S, then the line of reflection is going to be the perpendicular bisector of that segment connecting a point to its image. So what does that look like? If I connect point Q to point A, then the line of reflection has to be the perpendicular bisector of that segment. And same with if I connect R, if I connected R to B, there we go, then the line of reflection needs to be the perpendicular bisector of that segment. So I'm going to try to use that. So perpendicular bisector has to have a negative reciprocal slope, and it has to pass through the midpoint. I notice the midpoint of RB, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1, 2, 3, 4. And so that means that this is the midpoint. So my perpendicular bisector goes through that, and it's perpendicular. RB has a slope of over 1, down 1, negative 1. So the line of reflection would have a slope of positive 1. So my line of reflection, let's try a different color here, would look like this. And again, this is just a hypothesis. In order to see if that's actually going to be my line of reflection, I want to test it out. So I want to see if every point when I reflected over that line would map onto one of the other points. So to get from B, when I'm reflecting over a line with a slope of -1 or +1 or -1, this always works. I can count up to the line 1, 2, 3, 4, 5, 6, 7, 8, and then change direction 1, 2, 3, 4, 5, 6, 7, 8. So B maps onto R, that's good. A, 1, 2, 3, 1, 2, 3. A maps onto Q, that's good. And C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. C maps onto S, that's good. So a reflection over that line would do it. What's the equation of that line? I think slope-intercept form is going to be the easiest. I know it has a slope of 1, so my m is 1 or 1x or just x. My y-intercept is +4, so that would be a correct answer. But let's say I didn't see that. Let's say I wanted to take a few more steps, and I could. So another thing I could do, let's get all this out of here. My go-to method, if I'm not sure what else to do, is I start by translating the shape so that one of the points maps onto one of the other ones. So I would start by translating it by this vector right here, so that A maps onto Q. So I would translate it 4, 5, like that. So I would say let's start by translating triangle ABC up 3 units and to the right 3 units. or to the left 3 units. Sorry about that. And then I could rotate it 90 degrees counterclockwise around point Q. Because if I did that, a rotation 90 degrees counterclockwise would form that, followed by a rotation 90 degrees counterclockwise around Q. It's important you say what point you're rotating it around. And then if I do my last step and reflect it over this line here, it would map onto QRS. So that line is x equals negative 1, 2, 3, 4, 5, followed by a reflection so that's another sequence of transformation. So I have one, a reflection over y equals x plus 4, or I've got this sequence right here. And again, there are multiple answers, so it's important to check and test it out as you go. Number 29 at construction, and particularly, it's a deceptively simple construction. It's not one of the standard ones I'd imagine that you're taught. It's requiring you to use a little bit of knowledge about parallelograms, about construction, segments, all of that stuff. So we want to construct point D so that ABCD is a parallelogram. And like a lot of these problems, there are multiple ways to do it. There's not one right answer here. I take that back. There's one right answer, but there's not one right way to get that answer. I'm only going to show you one because I think it's the simplest and it's the thing that stands out the most to me. In order to do this problem appropriately, you really need to know all of those properties of parallelograms. And then kind of jump off from one of those points. So you could use the fact that a parallelogram has two pairs of opposite parallel sides. You could use the fact that it has two pairs of opposite congruent sides, that it has two pairs of opposite congruent angles, that the diagonals bisect each other. You can do this so many ways. The one I'm going to stick with is this because I find it really easy to construct congruent segments. These other ones to me take a little bit more work. Again, doable, just not as intuitive to me. So since a parallelogram has to have two pairs of opposite congruent sides, I know that whatever DC is, whatever that segment is, it has to be congruent to segment AB. And AB I can find the measurement of using my compass. So if I put my point on A and my pencil on B, I have a precise measurement for segment AB, which is great. And I could take this anywhere and say, okay, that's how long AB is, that's how long AB is, that distance between my point and my pencil hasn't changed. So that means if I put my point on C, and I draw an arc, any point that's on that arc is going to be congruent, is going to be equally far from C as B and A were from each other. So if I drew a segment connecting C to any point on here, that segment would be congruent to AB. And there's no other points, right? There's no other points besides the points that are on this full circle that are equal to that distance. So that means that I know that D has to lie somewhere on that circle with that radius. But how do I narrow it down? Because there's so many options. There's infinitely many points in here. So how do I know precisely which point I'm looking for? Well, I know that it doesn't just have one pair of opposite congruent sides. It has two pairs. So we know that AB and DC have to be congruent, but so do BC and AD. BC and AD also have to be congruent. So that means if I measure line segment BC, if I go ahead and measure line segment BC, and then I move this thing to A, the points I construct on this arc are equally distant from A that B and C were from each other. That means D has to lie somewhere on this green arc. Well, we said D had to lie somewhere on the red arc. It has to lie somewhere on the green arc. So there's really only one option for D at this point, and that's that it lies where the two arcs intersect. So this has to be point D. It says construct point D. We did that, so we've completed this construction. We'll get it full credit. If we really want to go for the gold, though, to make it really obvious that our work was correct, we should go ahead and connect. We should connect all four of the points because it'll make it really clear. A to B, B to C, C to D, and then D back to A. That's our parallelogram. On the last one that I'll do for now, on the set of axes below, DEF has vertices where they are, and point G has coordinates 3, 1. Owen claims the median from point E must pass through G. Is Owen correct? Oh, more vocab. I've got to know a median. So median, notice you've seen medians before with statistics. You've seen it in the middle of a highway, down the middle of a sidewalk. Median has something to do with middle. Should be where your head goes immediately. Specifically, a median connects, it's a line segment that connects a vertex, in this case of a triangle, to the midpoint of the opposite side. So the median of a triangle is something that connects a vertex of the triangle to a midpoint of the opposite side. So if we want the median from point E, then it would have to connect E to the midpoint of the opposite side, which is DF. So we want the median to pass through the midpoint of DF. Since Owen's claiming that it passes through G, Owen's claim is really that G is the midpoint. So we want to tell Owen whether or not he's right. Is G the midpoint? So we could go directly into our midpoint formula. The midpoint formula says that the x-coordinate is just the average of the x-coordinates of the segment we're trying to find the midpoint of. The y-coordinate of the midpoint is the average of the y-coordinates we're trying to find the midpoint of. Since we're using D and F, we want to show, find the midpoint of DF. So 1 plus 4 divided by 2, negative 1 plus 2 divided by 2, it's equal to 5 halves and 1 half, aka 2.5 and 0.5. Owen claimed that it was 3, 1, when in fact it is not 3, 1, it's 2.5, 1.5. The midpoint actually lies right there. So it is close, far off. So we would say that Owen is incorrect because a median must pass through the midpoint of DF. Since the midpoint of DF is 2.5 and 0.5, G is not the midpoint. Therefore, the median does not pass through G. And I'll pick up a little bit later with the last 5 questions. I hope this helps. Your Regents is in 24 hours, you'll be sitting and taking the Regents. So I hope this little bit of extra review helps.